Hello, algebra students. Mr. B here. All right, this is the first video of the examples for graphing rational functions. So here's our rational function, r of x equals p of x, the numerator polynomial you can see, and q of x, the denominator polynomial you can see. The thing is, we need to factor those, and I've already done that. You can see over to the right how these polynomials factor. And step one is to see if there's any common factor between the numerator and denominator. And we see that there's an x plus 1. So those would cancel. And we would just analyze what's left. And the other thing is, so I'll put a little step one here. We'll say we need to exclude the 0 that's associated with this factor. So that'd be -1, right? -1 would make either of those 0. So we are going to exclude -1 from the domain of r, our rational function, r of x. That just means we'll put a little open circle on the graph at -1, x equal -1. Okay, next, we'll get into the more wild stuff that we need, the details we need to graph this thing. First, we'll start with the x-intercepts. X-intercepts. And we know that those occur at the zeros of the numerator. And we have 1 here, it's 6. 6 would make the numerator 0. So x equals 6. And the multiplicity, you see a power 1 outside that binomial there. That means m is 1. And that means that the graph goes through the x-axis. Abbreviate through like that, goes through the x-axis. And there's no other x-intercepts, that's it. All right. 3, the y-intercepts. Intercept. There's only one, if there is one. It occurs at x equals 0. So we need to get the function, our rational function, at x equals 0. It's usually easiest to use the unfactored form, because then it's easy to see, like in the numerator, when you put 0 in for x, you're going to get 0 squared, which is 0, minus 5 times 0, which is 0, minus 6. And then in the denominator, 0 cubed is 0, plus 4 times 0, minus 7 times 0. So lots of zeros, except these last trailing, it's just minus 10 there. So after we kind of simplify it a little bit, we see we get -6 over -10. That's a positive number, right? Negative over a negative. Maybe we'll clean it up by dividing by 2, top and bottom. That'll leave us 3/5. So that's our y-intercept. Okay, next, we're going to get our vertical asymptotes. And those are at the zeros of the denominator. The zeros of the denominator. So what x values make the denominator 0? You can easily see it with the factored form. The first one is x equal 2. And we see that the multiplicity is 1. Right? There's a 1 there. A 1 power on that binomial. And that means that the graph is going to look like 1 over x. An odd multiplicity means it's going to be like 1 over x, which could be like this. Or we don't know what the sign is going to be, actually. It could be a -1 over x behavior, which would look like this. Now we don't care which one it is. We'll figure it out later. Okay. And then the other one is x. The other vertical asymptote is going to occur at -5. You see that? And its multiplicity again is 1. So we get the same kind of behavior. Okay, now how about the horizontal asymptote? Let's write that down. Horizontal asymptote. Asymptote. Should be able to spell asymptote. If I could write it clearly, you might be able to see how it's spelled. Anyway, that you figure out by looking at the highest power of the numerator and the highest power of the denominator for the variable x. And who wins here? Who's got a bigger power? If it's the denominator, like this case, then the horizontal asymptote is the x-axis, the y=0 line. I think in the general rules we called this top one n and the bottom one m. And so, anyway, n is less than m. N is, what was it, 2, and m was 3. So the y=0 line, the x-axis, is the horizontal asymptote. Okay, well, we're ready to graph. We've got all the details right there. So let's get a little room here, get some axes going, and start to put the details on here. This is the fun part. First of all, don't worry about 1 for now. We'll exclude the -1 from the domain later. X-intercepts, there's just 1, and it's x=6. So we'll go to 6. 1, 2, 3, 4, 5, 6. We'll put a dot there. And then the y-intercept, I think that was at like positive some fraction, right? It was, I don't remember what it was. It's 3/5. 3/5. That's a little bigger than a half. So I'm going to put that right there. And then we have our vertical asymptotes at 2 and -5. And we denote those with perhaps a dashed line. There's 2. We'll go to -5. 1, 2, 3, 4, 5. And then the horizontal asymptote is the x-axis. So we're done with that. It's already in place. Now, what's going on here? Where should we start? We should start somewhere where it's absolutely sure that, well, the details are unambiguous. I guess that's how we would put it. We know we have to go through the y-intercept right here. Let's look at this middle portion between the two vertical asymptotes. There are no x-intercepts in between those. That means the graph is not going through the x-axis anywhere between the two vertical asymptotes, but it has to go through the y-intercept. And since the graph has got to get closer and closer to those vertical asymptotes, it's got to look like this. Absolutely has to look like that. The behavior near those vertical asymptotes, right like that. Take a look at these pictures. That's what we're wondering about. It's got to be one of these. And I think that's what we've done, right? It's this case, actually, at least on the right. And on the left, it sort of looks like this one. Okay. So like I said before, you don't really know which one it is to begin with. Okay, Now, what else is happening? We've got, let's go to this right bit, branch to the right. So we know we have to go through the x-axis right here at 6. And what's got to happen near the vertical asymptote? Let's go back to those little thumbnails. We know it looks like this at the top. What's this saying it has to be at the bottom? It has to peel off from the right at the bottom, like this. And then it's going to come up through the x-intercept, and then it's got to get closer and closer to the x-axis because that's the horizontal asymptote. All right? And by the same logic, the graph has to go like this at the left vertical asymptote, the one that's at 1, 2, 3, 4, -5 here. Why? Let's take a look at that thumbnail again. It looks like this at the top, so it's got to look like this at the bottom. The other one doesn't have that happening, right? The top doesn't work right. It's got to be this one. Okay. So that's almost it. Let's take care of step 1 now. We know at 1, was it 1 or -1? I don't remember. Need to exclude -1 from the domain. Okay, -1. That's this x. What that means is we got to put an open circle right there in the graph. That means that that point is not part of the graph. -1, well, whatever value it is. I don't really care what the y value is. I just want to put an open circle on the sketch of my graph. I can call that y. Are there any other? Let's see, I should put a 2 there. Maybe put a 1 there to denote where that is. I think that's about it. All right. We'll see you in the next video.